Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with this paper, Pure Maths P3, May-June 2024, variant 33. It's 1208, 1209 approximately. Let's get started. It's a walkthrough solution. Now, the first question that we see over here, this is about a perfect question of indices and logs. And there are certain things that needs to be clarified in this particular thing. A lot of people have a confusion. That confusion is, what are the different ways of solving this particular question? So let me do it using method 1, in which I'll first simplify using indices, exponent, and then apply logarithm, which is a must. Now let's get started with this. First of all, you can see I broke this up, a raised to power of m plus n, a power m into a power n. This 4 as it is, 5 raised to power of negative 2x, I took it down. Then 8 raised to power of 3 at the top, this goes at the bottom. 4 is at the top, this was already at the bottom. All the terms with x in it on one side, all the other constants on one side. This rule over here, let me highlight this thing over here, this thing over here, which is the rule that is applicable. That is a power m raised to power of n, that is a m n. So if two powers are multiplying, separate it out. So now 5 raised to power of 2 is 25, 8 raised to power of 6 is this big number. They both have a power of x. And then apply this rule. Which rule is this? A over b raised to power of m. That is a power m divided by b power m. So that is another rule that is applied over here in the scenario. So you take x common out. And then at this point, we are taking logarithm of both sides. So if we take log of both sides, so what do? We say if y is equals to a raised to power of x, then log y base a equals to x. So that is the application over here. The base that I've taken is base 10. I could have taken base ln also, base e. So that's not an issue. Let me put a base 10 over here. And then this is like this is like this. And now look over here. So this is the same thing, 25 over 262, 144. This is 1 over 128. And then you can write it in decimals also. Let me also write this thing as 1 over 128. And the rule that we apply over here is this thing. Let me use the red color again. That is log x raised to power of m base a, the power comes down and multiplies. So at every position, you should know what exactly is happening. And then we should also know that log of any number between 0 and 1 is negative. So log of any number between 0 and 1 is negative. So there is a negative over here, there is a negative over here, divides, we get a positive thing, and this is the answer, correct to 3 decimal places. How many marks are they giving? 4 marks. Of course, it would involve a lot of working. Now, let's go to the next approach. The same question done in method number 2. So in method number 2, take logs from the beginning, and I think most people apply this concept. Take log from the beginning and then proceed. So just have a good look at it. What have I done? If I write log to the base 10, that is the same thing as log or lg. So it doesn't make a difference. So log to the base 10 can also be written as log, could also be written as lg. They all mean the same thing. So when I take log of both sides, I just need to push things to the left. Okay. And let me put some things over here. And the first thing that I need to put in is over here. That is again this thing, log x power m base a, that is m log x base a. So over here, this power 3 minus 6x, negative 2x, this comes down and multiplies, this comes down and multiplies. What is happening over here? This is multiplication, this is addition, this is addition. So the next rule is this thing, log xy base a, that is log x base a plus log y base a. That is the second thing that is applied. Now, then you open this up, you transfer all the x terms on one side. So where are the x terms? There is an x term over here. So there is an x term over here. There is an x term over here. So this x is there, this x is there. Take that x common out. And now look at the working. This is exactly the same thing as the previous one. Because over here, this 4 over 8 cube and this 5 square over 8 power 6. This is 5 square, 8 power 6, 4 over 8 cube with a cube. And all these things, this is exactly the same thing. This is 2 cube cube. And this is over here. This is power multiplies. Let me just do my small correction over here. This is 8 power 9. I think I wrote it upside down. And then you simplify, and then you get this answer. So it's right over here. So this is one method. This is the other method. It's your choice which one you want to apply. That is question number 1. Question number 2, it's about the concept of stationary points. So it's stationary points, it's differentiation, it's with exponential, it's with trig, it's about product rule. Just look at the working, pretty straightforward. U, V prime, V, U prime. There it is. This is U, U prime. And then there is V, V prime. So this is U, V prime plus V, U prime. Always make a habit of taking common wherever possible. I took this as common. Dy by dx is equals to 0. Write stationary points over here. E raised to any power will never be 0. No solution. You solve this thing. There are 4 steps over here. The first step is the quadrant because of the negative sign. The second step is that modification of range. So x lies between 0 and pi by 2. Therefore, 2x lies between 0 and pi. Third step, calculation of the basic angle, always with a positive ratio. Fourth step, we are only dealing with one quadrant. That is the second quadrant. Therefore, x is this thing. X is 3 pi by 8. Plug in the equation and you get this thing. That is the answer for this, and that is the coordinate. This is the working that I did for myself. Now, look at the spacing. A lot of people, they always are always hesitant about the spacing. I think the spacing is more than enough. And you just have to be clear-headed in exactly what you are doing. If you are not clear-headed, of course, there is a problem. So let me write this thing over here. That is, you need to have clarity in what you are doing. So that clarity over here is about the usage of product rule. That is one thing. The second thing is about usage of this basic differentiation. Then it's about the concept of stationary points. And then it's about a trig equation. And of course, you have to work in radians for differentiation, integration, numerical solution, differential equations. And this is for 5 marks. 5 marks out of 75. Keep that in mind. Every single mark is worth it. Now the next one. That is over here. Read the question. The square root of 24 minus 7i can be expressed in the Cartesian form where x and y are real and exact. Underline this thing. They are real and they are exact. That means, yes, it's a complex number, but the coefficients are real. So coefficients are real and exact. So keep that in mind. By first forming a quartic equation in x or y, find the square root of this thing in the exact form. So now the examiner never gave a hint before. This is the first time that they are giving us a hint. We know that this is a disguised quadratic equation. So now we have solved this question many times before, not a big deal, but this is the first time that they have given us a hint. So square root of this thing, it's equals to a complex number. Square both sides, square it actually. And this is I square, y square. I square is -1. Remember this basic rule. Of course, it's part of your mindset now that you have to use I square is -1. That is the part and parcel of complex number. Now, this is the real part. Let me highlight this. So this part is the real part. This part is the real part. And this part, 2xyi, that is the imaginary part, -7. 2xyi is -7, I cancel. So this is equation number 1, and that is equation number 2. So this is equation number 1, this is equation number 2. Solve it simultaneously, make y the subject. I plug this thing y over here. So this is -7 over 2x, that goes over here, square, cross multiply. And this is the quartic equation that the examiner was talking about. This is a quartic equation. Of course, this is a disguised quadratic equation. So let m is equals to x squared. So let me highlight this. Let m equals to x squared. Therefore, m squared is x power 4. You get this equation. Use a quadratic formula. You get m as -12. You get m as 24 over 5. But m is x squared. So x squared is -12. No solution. Why? Because if I take the solution, it won't be real. So that is why we discard it. X squared is 24.5, 24.5, 49 over 2. I'm working in third form. So these are the two answers that I'm getting. One of the answer is x equals to -7 over √2. The other answer is x is +7 over √2. Now find the corresponding value of y. For y, work it out. So therefore, the y value is +√2 over 2. And the y value over here is -√2 over 2. A negative value is giving you a positive number. A positive value is giving you a negative number. That is the final answer for this particular question. So let me just highlight this in blue color so that you can just make sense of it. So that is how this question is done. Again, it's for 5 marks, nothing special, but of course it's P3, so don't expect any shortcuts. Question number 4. Now, question number 4, what is this about? This is a linear law. Have a look. First, have a good look. Then I'll do the narration. Now, it's ln y against x. There are 2 points. An equation is given, and then you have to find the unknown constants. That's a usual thing, nothing special. So step number 1 is what? Step number 1 is coordinate geometry. Find the gradient. That's right over here. Plug in this equation, the gradient, and find the y-intercept. That's right over here. That is coordinate geometry. That is step number 1. So let me write over here. This is step number 1. And the next thing, that is step number 2. That's right over here. That is playing with this equation. So let me just remove this thing. I think I just put a C over here with this symbol so that you don't mix it up. Ky is e raised to power of cx. I think so. They should not give any constant which we normally use. Y is equals to mx plus c. They could have worked with some other thing. Take natural log of both sides. This cx comes down and multiplies. Multiplication, it becomes addition. Make ln y the subject. That is y is equals to mx plus c. So therefore, over here, you can write it that m is equals to the c. That is the constant that you have to find. And this y-intercept, this c is that y-intercept c, that is equals to negative ln of k. Now we are working with this. And now this is like step number 3, working towards the final answer. So now this c, the constant that they have given, this is equals to m. M is right over here. Therefore, c is this thing, 2 significant figures. And then negative ln k is c. This negative ln k is c. The y-intercept is over here. So therefore, let me just change the color to black. And it's right over here. So over here, this c, this m is this red one. That was this red m over here. And over here, this blue c is right like this. So this c is this thing. And then you make k the subject. So therefore, we have this thing. That is c comes out to be 0.80, k comes out to be 6.5, 2 dp, 2 significant figures. I think it's 2 sf. Well, in this case, the 2 dp is 2 sf. So let me write it. So this is 2 sf. Sometimes it is dp also. Got the idea? So that's the final answer. Make a habit of writing it at the end. C is equals to 0.80, K is equals to 6.5. Both answers are given to 2 significant figures. So I hope this is all got all clear. Question number 5. What is this about? Question number 5, it's about partial fraction. Only partial fraction? Yes. Usually it comes with integration. Usually it comes with binomial, but this time this is only partial fraction. Let me just double check one thing. Yes, the recording is on. All good, all clear. Now, first of all, the checklist. The very first checklist is it a proper versus improper algebraic fraction? So if the highest powers are the same, in the numerator, the highest power is 2. In the denominator, highest power is 2. Therefore, yes, the highest powers are the same. Therefore, it's an improper fraction. Therefore, step 1 is make it proper. So in step 1, the first thing is multiply out the denominator. Step 2 is long division. Step 3, write this thing as quotient plus remainder over divisor. So this is step 1. That is basically converting from improper to proper. All this working is for this. So the first step is pretty obvious. Second step, the powers are the same. One step of long division, 6x squared over 2x squared is 3. Multiply with each term, write it over here, change the sign and add. Therefore, this one is the quotient. This one is the remainder. This one is the divisor. So this is quotient. Let me write it properly. This is quotient. This is remainder. This is divisor. And the divisor in its original form is this thing. So 3 plus this thing over this thing. Now we are starting our working with this thing. And now you break this thing up. So now we have to do partial fraction of this thing. Which case is this? Denominator with linear factors. So now this is a constant over the first factor, another constant over the other factor. You take LCM, you equate, all this basic scenario is there. So you first find the value of A, that comes out to be 2. And usually what I can do is that I can say 2x plus 1 equals to 0, x is negative half. I could have done this way, but this time what I did is that I plugged in the value of A and I chose an easy number and I found the value of B. So A and B is there, and then make sure you write the final answer. Don't forget the quotient and then A over something, B over something. That's how this thing is written. Okay, so it's all about partial fraction. It's good that they asked it separately. Question number 6, read this part, evaluate the scenario. It says on an Argand diagram, shade the region whose points represent complex number Z which satisfy both the inequalities. Now this first inequality over here, less than or equal to 2, first make sure that you do the proper adjustment. So let me get the red color ready. That is this thing. The adjustment is done. It's a circle. The center is 4 and 3i. Radius is 2 units. The next one, again, the adjustment is needed. That is this minus on the outside. This is a half line. That is the starting point. And the angle is this thing. So this one is the starting point. It's not a stationary point, the starting point. Now, let's label the y-axis as imaginary, x-axis as real. This is 4, 3. That is the center. This is just a rough diagram, realistic. And the half line is starting from 2, 1. It's making an angle of 60 degrees like this. It's inside the circle above this half line because it's greater. So therefore, this region is shaded. All good? Now, this purple line is for the next part. Calculate the greatest value for points in this region. And I've drawn it separately also. So let me draw the color correctly. And this thing, let me make it purple. Okay. And then I'm not interested in the green line as such. I'm interested in this line. Okay. So now calculate the greatest value for argument of Z for points in this region. So basically, I need to calculate this whole angle over here. So what I can do is that let me draw a line like this. Let me calculate this angle over here. And then let me calculate this angle over here. That is what I'm doing. So let me draw a blue line from here to here. Not this thick. The blue line from here to here. That is what I've drawn. And let me join it with an orange marker like this. That is what is happening. So now over here, this thing is drawn on the outside. You want me to label it? I can label it. So this is 0. And let me make it thinner. It's kind of a little bit thicker. So now first the orange thing. Okay. This is like this. And this blue one is like this. Okay. So now over here, let me label this as O. This thing, let me label this as C. This thing as A. And over here, if I label this as point B. So O, B, C, A. This is O. This is B. This is C. This is A. That's how it's done. Now just have a good look at it. If I look at this triangle, which is OBC, I find the length. So this is focus on this triangle. So this is triangle OBC. And I find this thing, the length of the hypotenuse. I can even use tangent. That is for the other one. My bad. That is OAC. So first of all, I have used this thing. Let me just focus on this. Over here, up till here, this is finding the distance. That is one thing. Let's remove it. Now I'm focusing on this triangle. That is OCB. This is 2 and this is 5 and I'm finding 5. So OAC. So this is triangle OAC. So this is triangle OAC. So this is triangle OAC and you find this angle. Then focus on triangle. This is OBC and then you find this thing. That is the next thing. Got it? We remove this thing. Okay. So now we found this thing. We found this angle. That is theta. We found this angle phi. You can use the calculator later. So therefore, maximum value of argument of z is theta plus phi, and this comes out to be 1.06 radians. So it's a question that has appeared before also. So now how many questions are done? 6 questions are done. Now let me just go to the first page. And 1234 and 6 questions down. So this is like 26 minutes for 6 questions. That means 45 minutes. I think 45 minutes normal working, you should be able to handle 6 questions. Okay. So this is recommended for first 6 questions. First 6 questions. Now over here, let's move back. It's 12:35. Let me write over here. So now I'm starting with question number 7. And this is question 7 start. This is 12:35. So I'm multiplying my time by 1.5 or something. I'm basically doing the whole thing, explaining it more than once. Of course, when you are doing it, you're not explaining it to someone. So now let's look at this. What is this thing? It says this is a cubic equation. Show that x plus 7 is a factor. Plug in -7. Use a calculator. It all adds up to 0. That is shown. Find the quotient when fx is divided by x plus 7. Therefore, make sure that your denominator will be 0 because it's a factor. First thing, 8x cubed over x, that is 8x squared. Multiply with both of them. Write it down. Change the sign and add. You get -2x squared. Pull this thing down. -2x squared over x, -2x. Repeat the same process. We are left with -3x. -3x over x is -3. Repeat the same process. You get a 0. Therefore, the quotient is this thing. And if they were asking us to factorize fx completely, so we would write fx is equals to x plus 7. And this is 8x squared minus 2x minus 3. And if further factorizable, go ahead and factorize. If it's the same, go ahead and factorize. If it's possible, go ahead and do it. All good, all clear? So that was a small question. Oh, it's related to this trigonometry. That's a nice connection. Linking factorization with coordinate geometry, and I think it's factorizable. Yes. Hence, solve the equation. Now, what do you see? 8 cos cube theta, 54 cos square theta, 17 cos theta. So 8, 54, -17, -21. 8, 54, -17, -21. X is replaced with cos theta. So write for yourself, X is replaced with cos theta. So basically, x plus 7, this is like that, x plus 7. And this is 8x squared minus 2 cos minus theta equals to 0. Cos theta is -7. Of course, there is no solution. So reject. And then work on this one. This is factorizable. That is good to hear. Now we are getting 2 answers. 2 cos theta plus 1, 4 cos theta minus 3. This is this thing. This is this thing. This is the range. This is for second and third quadrant because cosine is negative. This is positive, first and fourth quadrant. Over here, the basic angle is 60 degrees. Over here, basic angle is 41.4. This is 180 minus basic angle, 180 plus basic angle. This is basic angle itself, 360 minus basic angle. Make sure everything is within the specified range and make sure accuracy is all good. So this is 1 dp. This is work in 2 dp at least. And make sure you write the final answer in ascending order. Final answer, make sure write in ascending order. So that is the basic kind of a question that you see in this case. Question number 8. I think there is a lot of trigonometry in this particular paper, and sometimes, yes, this thing happens. So now more trigonometry. This one was trig equation based upon algebra. This is trig equation based upon compound angle. Let's see, what are they asking? Are they asking for compound angle? Are they asking for something else? We will soon find out. Now it says express 3 cosine 2x minus root 3 sine 2x in this form where r is positive, alpha is acute. Give the exact values of r and alpha. So now we have heard and we have studied, not just heard, a cosine theta plus b sine theta. This becomes converted to r cosine theta minus alpha. A negative sign will give us a positive value. And just ignore the negative sign. A square plus b square under root, that comes out to be r. And tan inverse of second coefficient over the first, that gives you the basic angle alpha for this part. So now a is 3, b is root 3, alpha, r is root 12, alpha is pi by 6. This is exact, this is exact. This is exact in third form. This is exact in terms of pi. Got it? So therefore, that is how you do the conversion. And guess what? What's the next part about? The next part is about integration. So it's not just trigonometry, it is trigonometry plus integration. And over here, this was factorization. This is about factorization plus trigonometry. So look at all the different linkages that they can do. So factorization and trigonometry, this is trigonometry and integration. That's right over here. Just look at the working. Find the exact value of this thing. The denominator is squared. So now this thing over here is what we started with, this thing on the inside. This thing is this thing. That is the conversion that we have done. And then when we square it, look at this. So root 12 square becomes 12. It goes on the outside. Cos bracket square is cos square theta. So theta is this thing. 1 over cos square is sec square. Integral of sec square is tangent. Don't forget to multiply it by coefficient, divide by coefficient of x, which is this 2 over here. So therefore, this 12 becomes 24. Or let me write it like this for simplicity. So that's 12 is there, and this 2 is there, and this 2 is this 2 from here. So this 2 is this 2 from here. Got it? And then we have this thing tangent, 2x plus pi by 6. So if I plug in pi by 12, it becomes pi by 6. So 2 into pi by 12 is pi by 6. Pi by 6 plus pi by 6 is pi by 3. So therefore, this is tangent of pi by 3. I mean, just look at all the working. I plugged in pi by 12. I plugged in pi by 12. I multiplied by 2. I added pi by 6. This is tangent of pi by 3, which is root 3. And when I plug in 0 over here, that is this 0 over here, that is this 0 over here, that becomes tangent of pi by 6. Tangent of pi by 6 is root 3 over 3. And this thing was this green one. All good? And this is, I took this root 3 common out. And then look at this. I took this root 3 common out over here. And I'm just doing all the division at the very end. 1 minus 1/3 is 2/3. So 1 minus 1/3 is 2/3 over here. That's right over here. That's 2 and that's 3. And then now we cancel it out. And this is the final answer. So unless and until you have a good grip of algebra and what you call taking care of exact values, taking care of exact angles and the ratios, doing this kind of problem would be difficult. So make sure that you're fully well prepared for it. Don't take anything for granted. Now let's look at question number 9. Read the question once again. And it says a shape in a container in the shape of a cuboid has a square base with side x and the height is this thing. So the base is a square, that is x by x. Let me make it thicker so that you can start thinking about it. This is x, this is x. And then what do we have? And then we have a height, which is 10 minus x over here. Now it says it is given that x varies with time, where t is positive. Naturally, the container decreases in volume at a rate which is inversely proportional to this thing. So it decreases. The container decreases in volume. So make sure that you round it, you highlight this. At a rate which is inversely proportional to t. And then we have this condition when t is 1 over 10, x is half, and the rate of decrease of x is 20 over 37. You have to take care of a lot of negative signs. And then it says, show that x and t satisfies this differential equation, and then solve this differential equation, obtaining an expression for t in terms of x. So now this is for how much? This is 5 and this is 6, 11 marks. All good? So now, the very first thing, that is over here. This is step number 1. Let me label it. So this is step number 1. That is negative because it's a decrease. Negative rate is proportional to 1 over t. Negative dv by dt is k over t. That's the first thing. The second thing, the step 2. That is v is the square base area into height. That comes out to be this. We get volume. Therefore, dv by dx is this much. That is the second step. Then we have step number 3. That is from P1. That is rates of change. Very, very important. Nowadays, it's again in. It's in fashion. It's in vogue. So expect something like this in 2025 also. So we have v, x and t, dv by dt, dv by dx into dx by dt, make dx by dt the subject. That is dv by dt divided by dv by dx. This is again dv by dt divided by dv by dx. This is dx by dt. Now we are working it out. This is continuation of step 3. Step 3 continued. So now over here, this is negative k over t. This is divided by 20x minus 3x squared, negative k over this thing. Now plug in the condition. So now starting with step number 4. So step 4 is plug in the condition. T is 1 over 10, x is half, dx by dt is 20 over 37. This is a decrease. So therefore, the negative sign is over here. This negative cancels out. Look at all the fractions. K comes out to be a beautiful number, which is half. And hence, you have obtained the differential equation, d phi q, in terms of t and x. That is the first thing, and that is for 5 months. Have a very good look at it. Start from the right hand, actually the top. That is the first step, and then the second step, and then the third step. Third step continued. Fourth step. So now you need to do all this thing. There are no shortcuts. Let's move on. Solve the differential equation. Now, when we solve this differential equation, we have this thing. I took this k on this side. This is half. This is half. And this is t. And this dt is over here. And I took this negative on the other side. So there is this negative going on the other side. And hold for a second. There is this negative on the other side. There is this half on this side. And then also double check. There is dt. There is 1 over t. And then there is, let me choose the purple color. That is the x term, the dx. First write it. Then write the statement, integrate both sides. And as far as the constant of integration is concerned, we write on only one side. Doesn't make a difference which side it is. Since I have to make t the subject, I wrote it on that side. But as such, it doesn't make a difference. So 1 over t after integration is ln t, basic integration, basic algebraic integration plus c. When I plug in this condition over here, that is the condition, t is 1 over 10, x is half. Therefore, c comes out to be this thing, 19 over 8, half ln 1 over 10. Expect the unexpected. Remember the rule? Expect the unexpected. And then the last thing, that is, we are working on that. That is, place everything where it belongs. This is the integration. This is the c over here. Take the 2 on that side, multiply by 2, multiply by 2, multiply by 2, 2 and 2 cancels out. Then t is e raised to power of this thing. This rule comes into action. A very, very important rule. E raised to power of ln x is x, provided x is greater than 0. So therefore, e raised to power of this thing is this. So this is, I can add one more step to make life simpler for you. So therefore, this is, let me write it over here. T is equals to e raised to power of 2x cubed minus 20x squared plus 19 over 4 into e raised to power of ln 1 over 10. So this is an application of this. So therefore, this 1 over 10 comes down and multiplies. And let me highlight it with this color. Where is this color gone? There was this blue color over here. I think that must be this one. So this 1 over 10 is like this. That's how you get 1 over 10. And then the rest of the thing remains as it is. So now we started the clock again. I think at this time, I think question number 7. So 7, 8, 9. I think we did 3 questions. Hold for a second. Yeah, 7, 8, 9, 3 questions. And how much time was taken? I'm just looking for that page. So now this is over here. This is 12:50. So 15 minutes for walkthrough solution. I think 7, 8, and 9. So I think I'll give it half an hour. Let me go to the top page because timing is everything. So now over here, question number 7, 8, and 9, 3 questions. So keep 30 minutes for yourself. This is again recommended. So 30 minutes for this, 7, 8, 9. And now the last one is questions, I think 10 and 11, or maybe 10, 11, 12, something like that. So I think if it's 2 questions, again, 30 minutes for this one. And this is the maximum time that I'm talking about. I mean, try doing it in lesser time. And over here, I think this is the one. So now I'm starting the clock at 12:51. So this is question 10 and then question 11. So question 10, 11, I think I'll solve it in 10 to 12 minutes. So recommended for you people. I think this is not that great. Recommended should be maximum 20 to 25 minutes. With double checking and everything. Now let's have a look at this question. It says R is equals to 1, 1, 2A. And this is lambda 3, 4, and A. So there are 2 A's that I see over here. Mark it down. So there are 3 A's over here. There is this A, there is this A. There are no A's over there. The lambda is over here. So let me write this as lambda. And over here, this is mu. Now, where A is a constant, now keep in mind that this paragraph over here, for which I'm drawing a line like this. So this paragraph over here, it's applicable for everything. So this is applicable for the whole question. This is for all the parts. The same thing. Now, first of all, it's asking us that what needs to be done? Calculate the acute angle. Given that the acute angle between the directions of these lines is pi by 4, Find the possible values of A. Now, first thing, if I talk about the first line, let me call this as the blue line. And this one, let me call it as the green line. So for the blue line, this is direction vector 1. This is magnitude of direction vector 1. This is direction vector 2. This is magnitude of direction vector 2. And then we have this thing, the pi by 4. So cos of pi by 4. Cos of pi by 4, I can write in the rationalized form or the unrationalized form. So let me just put this thing on the side over here. Let me pull this thing up. And it goes like this. So now over here, this is line 1. So this is line 1 direction vector. This is line 1 magnitude. This is line 2 direction vector. This is line 2 magnitude. Of course, you can write the blue with the blue and the green with the green. Now over here, I'm writing root 9 deliberately as root 9. I'm not taking the square root. Why? Because look at all the working. Focus on that. Focus on this thing. That is 25 plus a square. Focus on root 9. Focus on 1 over root 2. So there is the square root over here. There is this square root over here. There is this square root over here. Collect all of these pieces together and put them in one big square root. So let me write this thing in one big square root. Hold for a second. Let me move this thing up. So now when I talk about the square root, so that is like this. And that is like this. Now, after the simplification of the other side, this thing, 2a plus 5. Square both sides. So the square root disappears. So first of all, from here to here, that is square both sides. Annotate it as much as possible in order to gain maximum marks. And then you cross multiply, you get this equation. It's your choice, middle term factorization. It's your choice, quadratic formula. The main thing is show all working. Remember these 3 words and you will get your desired grade with effort, of course, and hard work. So you get A is 5 and A is this thing. So A is 5, A is 35. That is the answer. So basically, it's working with what you call the dot product, the scalar product. Also, let me focus on this. I into I, J into J, K into K, and then you add it up. I skipped this part. I focused on it again. Now it says given instead. That means now the scenario has changed. And now it's saying given instead that the lines intersect. They are not making an angle of 45 degrees. They are intersecting, and don't use the previous value of A. Find the value of A and the position vector of the point of intersection. So remember, there was this A over here that was in pink color. So that A over here, the pink color one, that's A is over here. That A is over here. You expanded both the equations. You have in terms of lambda, that is the blue and the green. So you have the blue lambda over here. Make sure you have the lambda, 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 and the green, the mu, and the mu, and the mu. Now, when 2 lines intersect, the x coordinate equals to the x. That's one equation. The y coordinate equals the y. That is the second equation. You solve it simultaneously. You get the value of lambda is 1 and -1 and mu is -1. So let me focus on this. So therefore, lambda is -1, mu is -1. Check in third equation if it satisfies all 3 equations. Because before that, my bad. So this thing should be a little bit down. First, we find the value of A. So plug in equation 3. Actually, you don't need to check because it says it intersects. So just skip this thing. So you just plug in equation 3 because that's the only one that's remaining. And of course, it's intersecting. We find the value of A. Now, either place lambda and A in equation 1 or place mu in equation 2. So I have shown the working for equation 1. Let me show the working for equation 2. Minus 3 minus mu. So this is negative 3 negative mu. And then it is negative 1 plus 2 mu, negative 1 plus 2 times mu. And this is 4 plus 2 mu. This is 4 plus 2 times mu. How much is mu? Mu is negative 1. So this is negative 1, negative 1, negative 1. Put a bracket, write this thing R, or that's another option. So negative 3 plus 1 is negative 2. Negative 1 plus 2 is negative 1. Negative 2 is negative 3. 4 minus 2 is 2. That is again the same thing. That is the position vector of the point of intersection. So you can also do it like this. Whichever one you feel is easier, just go ahead and do it. Now, this question number 11, what does it say? Use the substitution 2x is equals to tan theta to find the exact value. I'll be using this identity. And the limits are 0 and half, 12 over 1 plus 4x square dx. Give your answer in this form where a and b are rational numbers. Step 1, 2x is tangent theta. So that is what is given to us. So 2x is tangent theta, x is half tan theta, therefore dx is half sec square theta d theta. So there is this half, this is sec square theta d theta. This is step number 1. So let me write over here, this is step number 1. Then it says, let's focus on the denominator, 1 plus 4x square. So again, let me choose another color. Let me choose blue color. That is 2x square, that is 4x square. Tangent theta square, that is tan square theta. So therefore, this is 1 plus 4x square. Let me write one more step and let me push this limits downwards. And let me put it over here. So therefore, 1 plus 4x square actually becomes 1 plus tan square theta. So now focus on the blue thing. That is 1 plus 4x square is 1 plus tan square theta. So that is right over here. That is 1 plus tan square theta. Got the idea? Denominator is already taken care of. There is a square on the outside. There is a square on the outside. So 1 plus tan square is 6 square. That is the first thing. And don't forget, there is a square on the outside. So when you do the division, you are getting this. 1 plus 6 square is cos square. Now, compare this with one of the question in which I think it was 1 over cos square. That became 6 square. So I think the examiner loves trigonometry too much. Now we have this thing, use double angle identity. That is cos square theta. The short form, that is half 1 plus cos 2 theta. So now we are using this double angle identity over here. That is right over here. And we are using this. So now this red shading is for this thing, 1 plus cos 2 theta. This 2 is there on the outside. 6 was there, 6 was cancelled. 12 divided by 2 became 6. Now 6 divided by 2 became 3. This is theta. After integration, integral of cos is positive sign. This 2 comes down and divides. Plug in the upper limit. So now let me plug in the upper limit, which is pi by 4. Hold for a second. So the upper limit is this thing, which is pi by 4. That is plugged in over here. That is plugged in over here. And the lower limit is this thing, which is 0. That is plugged in over here, plugged in over here. Now, one last thing. That was this thing, the limits. The original limits were 0 for x. Tangent theta is 0. Therefore, theta is 0. And the original limit for x was half. Tangent theta is 2x. So therefore, tangent theta is 1. Theta is pi by 4. Let me again make you work one more step. And that is over here. Tangent theta is 1. Therefore, theta is pi by 4. And then when we plug in over here, make sure 2 times pi by 4 is pi by 2. Sine of pi by 2 is 1. So sine of pi by 2 is 1. Therefore, we are getting this thing. and sine of 0 is 0, 0 is 0, and we are getting this answer, which is a plus b pi. So this is a, this is b pi. If you want to write the answer separately, you would write a as 3/2 and b as pi, ignore the pi, that is 3/4. That is how this answer is obtained. Now this is 103 and we started at, I forgot to write down the time. I think it took around like 10-12 minutes. So now just an analysis at the end. Divide the paper into 3 halves. So question number 1 till 6. Questions 1 till 6, that is 1. Questions 7, 8, and 9, that is the second one. Questions 10 and 11, that is the third one. Usually, this is recommended time for students, of course, not for teachers. It's for students. For this thing, max 45 minutes. With double checking. Don't wait for the end. Just go ahead, double check. Maximum 45 minutes. Don't exceed this limit. Otherwise, you will be in trouble. 7, 8, 9, max 25 minutes. Again, with double checking. And the last one, 10 and 11, that is max 25 minutes. Sometimes these ones are more trickier than this, or vice versa, that could happen. So 25 and 25 is 50, 50 plus 40, 90, 95 minutes. So this is like 95 minutes. How much time are you given? You are given 1 hour plus 50 minutes. That is 60 plus 50, that is 110 minutes. So if you finish comfortably by 95 minutes, still you skip one part, you can come back to it later. So just make sure that you follow this instruction if you want a nice grade. The first 6 questions, maximum 45 minutes, 7, 8, 9, maximum 25 minutes, 10, 11, maximum 25 minutes, and then you are all set to go. So which paper was this? This was May, June 2024, variant 33 of P3, all done and dusted. Stay tuned for more content on Mathematics with Shahab Yaqub.